demarcating, density is clearly demarcating the composition of our Earth's parts. Let's have a more deep dive. So when the density is greater, speed would also greater. The density is greater, speed would also greater. If the medium is changed, speed would also. See, pay attention. Here we have what? Crust. So this is what the P waves. So when the crust is there and as you move in the deeper part of crust, the density of rocks will increase, and as the density of rocks will increase, what we can say, then if the density of rocks will increase, the velocity or the speed will increase of both waves increase. Then we have a some sort of reduction in speed, probably because of asthenosphere, we can say. Okay. Then when you are in the asthenosphere itself, the speed will be lesser because of the changed density. So based on this pattern, we say that when the density is decreasing, it's mean, when the speed is actually decreasing, it's mean the density is somewhat different, or there might be a situation that medium could be different. So here we have a what? Medium which is different, plastic nature is there. Then again, like we have a upper mantle, and upper mantle will show us some pattern of randomly increasing, gradually increasing velocity. And here we have what? One sudden increase when it is passing through the upper mantle. Let's continue from the upper mantle. After the upper mantle, when there is a lower mantle, we have some sort of changes, we have some sort of increase, and suddenly when there is an outer core, so P wave would going to reduce in terms of its speed. Why there is a reduction in the speed? Because the medium is getting changed. Here the outer core is liquid, so when the medium is changing, speed will change. Here speed is what? Comparatively, and S-wave is completely absent when in the outer core. And when there is an inner core, in the inner core we have a more density, so if the density will be more, speed will be more. So here the seismic waves speed is more. Okay, so the behavior or the speed of these seismic waves throughout the different layers of our Earth's interior, throughout the crust, lithosphere, asthenosphere, upper mantle, lower mantle, outer core, inner core, based on these two set of aspects, that if the density is changed, speed will be changed. The density is more, speed will be more. If medium is changed, speed will be changed. So we have a same thing here. Here if you see lithosphere, so here in this image you will see lithosphere. So in lithosphere we have a what? Some sort of, let's say, increasing density. If you are moving from crust up to the depth of 200 kilometer lithosphere, so we have what? Increasing density of rocks. As the density of rocks is increasing, the velocity of seismic waves is increasing. Then suddenly we have what? Asthenosphere. So asthenosphere is plastic, density is medium is different. If the medium is different, the speed will reduce and the speed of both waves will reduce. Here you can see. Then we have a upper mantle. So in upper mantle we also have a increase in the speed as compared to the asthenosphere. Okay. Then if you are in the lower mantle, further you will see there is a gradual increase, then there is a sudden drop when P wave is about to enter core, and when this S wave is absent in output. So based on this particular pattern, we used to say that the density of rock is different in our earth crust. Our earth crust is comprised of different material in terms of their composition. Some are solid, some are liquid. Okay.